Hello, welcome back. So now that we have seen how our data set actually looks like, and what are all the columns it contains, and how the data is present in the form. But we just had a gist about the data set, right? So we don't know how many columns are there, how many rows are there, and what exactly data types of each of the columns, etc. So we'll try to understand more about our data set in this session. So we can consider that under pre-processing, text pre-processing step itself, because it is a preliminary step before we actually begin with the text cleaning process or a text pre-processing step, right? So without knowing a data set, we can't actually clean our data set, right? So just have a look about other parameters of the data set. That is, first, the shape of the data set. What does this means? df.shape function will give us the output as number of rows and number of columns. So in our data set, we have 71,044 rows and 25 different columns. So what does these 25 different columns says about, or what are these 25 columns? So we can have a look at that as well. df.columns will give us different column names or all the column names of the data set. So here are the columns present in the dataset. We have ID, brand, categories, date added, date updated, keys, manufacturer, reviews, review related aspects, etc. So this is about our column names for the dataset. So one thing you can just see over here is the columns are named as reviews.source URL, reviews.id, reviews.name, helpful, etc. So they have used a dot operator to combine two words, right? So instead, what we can do, we have a general convention when we define the field names, right? So we'll just use a underscore to separate two words, right? So I can replace reviews.date with reviews underscore date for better naming convention, right? So that will be the first step I will be going to do in this step over here. So column names equals to date, data frame dot columns, that is df dot columns. Then new column names equals to I dot replace what I am writing a list comprehension, right? So for I in column names, that is these are all the column names, right? The column names I have took in the variable column underscore name. So for all the values in the column names, I'm going to replace the dot with underscore. So I'm going to use this replace function present for a string. So string module contains for a string it contains a replace function. So I'm just using that in a comprehensive for loop. So I have just replaced that. Then now we have a look at it. You can clearly see that all the column names with reviews dot with something are replaced with reviews underscore and particular text. So this is one of the best naming convention which we have to actually follow coming to any data set, right? We can just use this because now once we have downloaded the data set, it's all ours. So we can do whatever we want when it comes to the naming of the columns. So now we have done that. Now let's understand what are all the data types of each of the column. So what exactly this category, what data type of categories present? So what data type is present in this column data added, date added? So we'll have a look at that as well. So we have a function in the df, that is data frame, that is df.d types. So what this will do, it will list out all the column names and the respective data type of particular column. So when I just run this, you can just see. So id is an object, then we have keys as an object. You can clearly see reviews id. Reviews id is in a float format, and review rating is in int format, integer basically. So all other things are in the object format. Okay, now we got a understanding about the number of rows, number of columns. We have replaced the column names. We have also known about the data types of each of the columns. What else we have? So we'll also try to understand, or we'll try to start cleaning the database, right, or data source or a data set. So to clean the data set, first understand what exactly. So when it comes to cleaning, we will have a major intuition about how many rows are actually containing the information in all the columns. Let's just have a look at that with the df.info function. So what does this will give out? It will give out all the column names basically on the left hand side, and it will give the count of each column, how many number of rows are actually not null. Okay, so taken a column, how many rows are actually not null. So what it in turn says that this, for this particular column there are these many number of non-empty values present in the particular column. So what we will get by this, we will get to understand how exactly our data is distributed, right? Okay, so you can clearly see the id has 7,100. We have total number of rows, that is 71,044, right? Here we actually saw that in the shape as well, right? So this is the number of rows we are available with. So out of 71044, id has all the values as not null. So it basically contains id as a primary key. We can use this as a primary key because it is a not null value, right? So yeah, so id, yeah, the almost up to date updated, it is a non-empty value. Suddenly you could see there is a column name called EAN and EAN, which actually contains almost 50% of the data as a empty value, and only 50% of the data is a non-empty value. Okay, we have to think about these kind of category, these kind of columns, whether to eliminate or keep these columns, whether they are actually useful in our model building process. Okay, now let's just have a look of other columns as well. Okay, clearly you could see there is another column called reviews underscore do recommended, and it is almost 6,429, right? Okay, that is, it's better than this, right? So better than half of the values being null. So it's less than the actual number of rows, but yeah, it's good to go. Then we have other things. Okay, these are the major blockers what we can see. So the reviews underscore user city and the reviews underscore user provenance are the two columns which have very least non-empty values. That is, in that particular column, almost all the values are actually null. You could clearly see that, right? So there are only 449 out of 71,044 rows are actually empty. So this, and also we can have a decision over these as well. So in the process of building a sentiment analyzer, do these two columns actually make sense to keep them? No, right? So the user city might not impact majorly on our sentiment, or user provenance may not make an impact on the sentiment of or a sentiment of a review for that particular product. So we will just define one thumb rule to eliminate the columns which are with a high number of empty values. So we'll just have another perspective for defining the missing value count. So we'll just use a function called df.isNull.sum. So what does it will do? It will sum up all the null values. So it is basically a opposite of what this info do. So it has just listed the non-null values. This df.isNull.sum will do the opposite of, like it will count the empty values present in that particular column. So you could see EN has 31,979 empty rows, and these two, user city and user provenance, almost have, this is almost all the actual data set rows, right? So it is almost all empty. So let's have a percentage look as well. See, we have the non-null values, number of non-null values. We have number of null values. If I divide this and this, that is missing value on top of non-missing values, we'll get a percentage of values present in the particular column. So I am just going to do that. Percentage of missing value per column is right. Tf dot is in what this will do, it will check. It's a boolean operator basically. So it will check each and every row whether it is an empty or not. Then it will take a mean. Then it will round it off to 4 decimals, and I multiply it by 100. It will give me a percentage of empty or the missing values present in a particular column. So this EAN has 45% of missing values. This did purchase as 54%, and clearly you could see these two are the major killers over here. So the user city and user provenance as 92 and 99% of the missing values. So clearly we have a clear decision to remove these two, basically these two columns, because they don't have any significant effect or prominence when we build the sentiment analyzer. Let's have a better look of these as well. So I'll try to use a visualization tool, that is heat map. Heat map is one of the visualization tool which we try to visualize the rows of the columns distribution. So it is present in the SNS module, so SNS library. In the import packages, you could just see that. Yep, over here. So the seaborn basically consists of a feature called heat map, which will try to picturize the distribution of the terms or the values in a given data frame. So let's just have a look for that. So okay, so I'm going to plot the missing values basically. So I have taken the SNS dot set. I am setting certain parameters of the figure size basically. So this is the figure which I have got. So this is the length and breadth of that particular picture. You can set this parameter with any values, and that will be the size of the picture which you will be going to get. So SNS.heatmap. So this is what I was speaking about. So SNS.heatmap, for this, it will be expecting certain data frame, right? So the data frame here would be data frame df dot is null. So I'm going to pass this. So it will check whether that particular row is a null or not. So what I am going to picturize is this particular thing into a pictorial form. So what is the distribution of the missing value in all the or the in the entire data frame? So you can set other parameters such as the rotations and font size, etc. You can set these, and finally you will going to plot this using plt.show. So what is this plt.show? It will actually display the picture in the console. Okay, this is what the picture which we got after plotting. So on the bottom you have all the columns listed out in the particular data frame. So we have all the column names here. On the y-axis we have the row count. Okay, so this is the row count, and this is the legend. So what does this legend says? 1 being the highest value, that is if that is this color white represent the missing value, and this color black represent the non-missing values, because we have plotted the data frame for the missing values, right? So this is the heat map for that. So clearly you could see the ID, brand, categories, date added and date updated have no empty values, right? So that's why there is no white patches available for these columns over here. Then our target or the killers over here, you could see the review city and the review provenance. You can see almost all the rows are just white. You can just see only few of them are being black, but most of the rows are actually missing values. When it compared to ID brand category, it is almost the opposite of what we have for that, right? So yeah, this heat map gave us another perspective or another picture of how the data or how the missing values are distributed in the given data frame. Now it's time to eliminate those columns. So we can just fix a thumb rule. Suppose we can have this rule anyway, but as a general practice, when we try to build a machine learning or any models, so a data frame with columns 70% missing values or 80% of missing values, we can just eliminate those particular columns. So this is the general rule which we follow. That is, in a data frame, if there are columns with more than 70 to 80% of the missing values, they are very less significant and we can drop those columns. So for that, what I'm going to do is missing value threshold. That is the thumb rule, right? That the threshold equals to length of the df into 0.2. So what does this do? It is trying to considering all the values with columns which have empty values greater than 80%. So this is the threshold value I'm going to set. Then this is the function which I'm going to drop, which I'm using to drop the column. So df dot drop na threshold equals to missing value threshold. You can see, you can set this parameter anyway. You can just name it as threshold. Fine, it's fine. You can use any parameter name. Then axis equals to 1. This is very important. The axis equals to 1 represent the rows. So it's going to, sorry, the axis equals to 1 represent the column. So we are going to drop those columns, right? So that is axis equals to 1. Then in place equals to 2. What does it will do? It will not only drop the columns temporarily, it will going to drop those columns permanently from the data frame we have. So suppose if you try to recall the previous data frame, it is not possible at this point. If we set this parameter in place equals to true, then those columns which we are going to drop are permanent. They will be removed permanent. So when I just run this and have a look at the columns remaining, you can't find those two, right? So you can just see there are no reviews dot user city and reviews dot user provenance. So we have just dropped out that. Now we could just see, oh, initially we had 25 columns. Now we are left with 23 columns. Okay, that's good. We not at all dropped a abundance of data, but we have sufficient data as well. It's good to go with this particular thing, right? Okay. Then I have decided other parameters like reviews.text or reviews.date. So we have other two columns, review.text and review.date column. So I'm going to check whether there are any empty values present in these two in those in these two particular columns, because reviews.text is our major target column which are going to analyze the sentiment based on this, and reviews date is basically to understand the trend of the reviews. So I'm going to check whether there are any empty values in these two columns specifically, and I'm going to drop that. So df.drop na subset equals to these two columns, then in place equals to true. So it will just drop the empty rows, only the rows, not the entire column, only the rows which are empty in these two particular columns. So after dropping that, now let's just have a look at the shape of the data set. You could clearly see that from 71,044, now it is reduced to 70,941. Cool. So we have not dropped major or large amount of rows as well. So we have just dropped only very few data which are empty basically in these two particular columns. Now just have a look of percentage again. Yeah, it is 45, 54, 14, 54. Yeah. So we have nothing We don't have columns left with a highest percentage of missing values. Cool. So now the data is very much ready to go further. Okay. So now we have cleaned a basic, or we have conducted a basic cleaning technique, that is dropping the missing values.